Welcome to this Fundamentals Lesson Plan series on doors and windows for layout and design. In this video, we'll take a look at applying a constraint to create a relationship to keep a door centered between two walls. This is video 3 of 4. My name is John Harridge, and I will be your host for today's lesson. Let's review the learning objectives for video 3. At the end of this lesson, you will be able to apply constraints to doors to create a parametric relationship to walls to capture design intent. And then we'll also take a look at how to reveal the actual dimension values when you use the EQ functionality for dimensions. With that, let's get started. Let me begin with an instructor demo. So if you would, just please watch and listen to this presentation, and I'll let you know when to jump back in. So the purpose of constraints is to build intelligence into the model by defining relationships and interdependencies between elements. So what I'm going to do now is I'll create four walls that are in the configuration of a rectangle. And then I will subdivide that space into 3 spaces internally. So I'm going to go ahead and pick up the wall tool, choose the rectangle layout method to establish 4 walls to create a rectangle. All right, zooming in here. Next, I want to subdivide that into 3 spaces. So let me pick up the line tool. I'll go ahead and draw the first wall segment here. And next, I'll establish the next internal partition wall. And again, deliberately, I'm making these spaces unequal. But the goal is to make these 3 spaces equal in size. Using your existing CAD knowledge, you could measure the distances between the walls and then figure out what the movement dimensions need to be. But there is a better way with building information modeling. We can simply create a continuous dimension string across the walls that we wish to establish a relationship with, and then enable what's called an EQ constraint to actually create a parametric relationship. So again, these are the 2 internal walls that I want to become equal to create those 3 spaces. And so I'll go to the Annotate tab, choose the Align Dimension tool, left click to acquire the first dimension witness line, and then left click at each of the other subsequent walls, and then drag off the model and left click to place. And then above the dimension string, you'll see that there's this EQ that has a slash on it, that icon, and that's an actionable icon. If I left click on that, I can activate the equalization, and you saw that the walls parametrically adjusted to this new rule. Let's look at these constraints in action. If I place this wall in a selection set and then using my left mouse button drag it to relocate it, notice that the constraints are maintained and that equal spacing is current. Now, to reveal the actual dimensions, if you select the dimension string and right click, you can actually toggle the EQ display. So I can now see the real dimension value behind that. So just to take this a step further, let me go ahead and place 2 window instances in this particular wall location and space. And again, let's take a look at constraints. I'll go ahead and place a continuous dimension string to space those windows equally along that particular wall length. So again, I'm creating witness lines at the center or midpoints of those windows, and then I'll go ahead and position this dimension string inside and then enable the EQ constraint. Now the windows adjust. Again, just to confirm, if I select this wall and relocate it, note that the windows and the internal walls are still maintaining the encoded relationships that I've established. Very cool. All right, let me go through another iteration of this. Let's open up the south elevation view just to show you that you can place windows in an elevation view. So I'll create similar. And this is to let you know that constraints can be encoded in any 2D orthogonal view. So initially we looked at the plan view relationship. Now we're going to look at the elevation view relationship. So now I go ahead and create a new permanent continuous dimension string to locate these windows. And then enable the EQ constraint. Windows are now spaced evenly. And just to confirm once again, let me select and highlight the left wall and relocate it. And note that the windows maintain that relationship along with the interior partition walls. This concludes this instructor demo. Let's return to the hands-on exercise. If you would, please go ahead and click Open and navigate to your tutorial directory, and let's open up Doors and Windows, Exercise 3. In this exercise, we'll go ahead and place a door along this wall that's highlighted on screen, and then we'll apply a EQ constraint to that relationship to keep it centered in that wall. So go ahead and start the Architectural tab, select the door placement tool. Let's use single flush 36 by 68, and let's go ahead and place an instance of the door anywhere along that wall, if you would, please. And now let's go ahead and select the Annotation tab. Let's go ahead and place our permanent dimensions, choose the Align Dimension tool. Go ahead and left click to set the first witness line on that wall. Left click to acquire the midpoint of the door, and then left click to establish the last witness line on the corridor wall. And then left click to locate the dimension string. To enable the EQ constraint, go ahead and click on the EQ icon, and you'll see that the door moves to that new rule-based relationship. Next, let's create another constraint. This will be an alignment constraint to make these two walls align and behave as one, so to speak. So I'll go to the Modify tab, and I'll select the Alignment tool. I want the left face of this wall to be the reference point. So I left click to accept that, and then I left click on the left face of the corridor wall to create that relationship. Now at the first point, it's just a move command, but if I select the padlock, that will now make it a permanent relationship, and now the wall should reflect that condition. Alright, so the next step is to reveal the actual dimension values for the permanent dimensions that are referring to the door. So if I select the EQ dimension string and right click in the canvas window, you'll see the EQ display toggle. Just left click on that once, and then that will display the real dimension values. So just to confirm that this is all working together in concert, go ahead and select that corridor wall and then override its temporary dimensions and enter in 16 feet and hit the enter key to accept. And everything should be working together. The door is still centered along that wall, and the two walls are still acting as one in that alignment relationship. Go ahead and perform a zoom to fit here. Let's go ahead and perform a save file as. So go back to your project directory. Let's call it Doors and Windows Exercise 03 finished. Go ahead and click Save after you give it a name. This concludes this exercise. Let's take a look at next steps. Let's review the learning objectives for video 3. In this lesson, you were able to apply a constraint to a door in a wall to create a centered parametric relationship along the wall. And then we looked at how to display the actual dimension values behind the permanent dimensions where it displayed EQ. With that, let's take a look at Autodesk resources that are available to you to continue your learning path. I would like to make you aware of two specific Autodesk resources. The first one being the Autodesk Education Community, where you can access free software for both students and educators, and that can be located at www.students.autodesk.com. It does require registration, and you can use either your own personal email address or a school-issued email address. The second resource is the Autodesk Digital STEAM Workshop. It's hands-on, project-based learning across multiple industries such as architecture, engineering, gaming, and animation. And those resources are located at www.digitalsteam.autodesk.com. This concludes this exercise. Thank you very much for watching.